Now in the question 8, 500 earthworms were collected from a sample of soil A and 500 earthworms from soil B, and their lengths were measured. The commutator frequency curve below shows the length x millimeters and the number of earthworms which have lengths less than or equal to x millimeters. So in the part 1, which soil was the shortest earthworm among the 1000 earthworms found in? To solve the part 1, first we have to understand the scale along x-axis, and here we have for x-axis 20 minus 0 divided by total number of squares between these 2 points, and that is 10. So here we have 20 over 10, that will be equals to 2. So each square unit along x-axis is equals to 2. Now the scale along y-axis, we have 100 minus 0 divided by total number of squares between these 2 points, and that is 10. So 100 divided by 10 will be equals to 10. So each square unit along y-axis is equals to 10. Now we will observe the graph to find the shortest earthworm length for soil A. So the shortest earthworm in soil A is approximately equals to, so from the graph, since we know the scale along x-axis, so the first point is 0, second is 2, 4, 6, 8, so here we have 10. So the shortest earthworm in soil A is equals to 10 millimeter from the curve. Similarly, the shortest earthworm in soil B can be found out from the commutator frequency curve. So along x-axis we have each square unit is equals to 2, so we have 20, 22, 24, 26, 28 and 30. It is approximately equals to 30. So the shortest earthworm in the soil B is equals to 30 millimeters. So we have find out the shortest earthworm in both the soil A and soil B, and the shortest earthworm in the soil A was equals to 10 millimeter of length 10 millimeters, and the shortest earthworm in the soil B was length of 30 millimeters. So from comparing these two values, we can say that the shortest earthworm among the 1000 earthworms was found in soil A. So the shortest earthworm among the 1000 earthworms was found in soil A. The part 2, earthworms which grew more than 60 millimeters are said to be satisfactory. Which soil had more satisfactory earthworms? Explain. So from the graph, number of earthworms from soil A with length less than or equals to 60 millimeters is equals to, now from 60, along x-axis we will draw a vertical line until it touches the cumulative frequency curve representing the soil A. And now from point of intersection on the curve, we will draw a horizontal line until it touches the vertical axis. Now from the point of intersection on the curve, we will draw a horizontal line until it touches the vertical axis. And since we know that each square unit along y-axis is equals to 10, so we have 300, 310 and 320. So the values is approximately equals to 320. Now to find out the number of earthworms from soil A with lengths more than 60 millimeters is equals can be obtained by subtracting the number of earthworms from the soil A with lengths less than or equals to 60 from the total number of earthworms collected from a sample of soil A, and that was 500. So we will subtract 320 from 500 and we will get 180. So the number of earthworms from soil A with lengths more than 60 millimeters is equals to 180. Now from the graph, the number of earthworms from soil B with length less than equals to 60 millimeters can be found out by extended the vertical line from the point of 60 until it cuts the curve representing the soil B. Now from point of intersection on the curve representing soil B, we will draw a horizontal line until it touches the vertical axis or y-axis. Now here we have the value 320, 340, 360, 350, 360, 370, and here we have approximately value 380. So the number of earthworms from soil B with length less than equals to 60 millimeters is equals to 380. Now to find out the number of earthworms from soil B with lengths more than 60 millimeters can be found out by subtracting the number of earthworms from soil B with length less than or equals to 60 millimeters from the total number of earthworms were collected from the sample of soil B, and that was 500. So we will subtract 380 from 500 and it will give us 120. So the number of earthworms from soil B with lengths more than 60 millimeters is equals to 120. So the number of earthworms longer than 60 millimeters from the soil A is equals to 180, and the number of earthworms found from the soil B with the length longer than 60 millimeter is 120, and since the soil A has the larger value 180, so soil A had more satisfactory earthworms. So soil A has more satisfactory earthworms. Now in the question 9, the histogram represents the ages and the years of 50 children. So here we have the histogram showing the ages, the 50 children. In the part 1 we have to find out the range. So to find out the range, we will use the formula largest age minus the smallest age. Of the largest age along x-axis is 9 and the smallest age is 3, so 9 minus 3 is equals to 6, so range will be equals to 6. First we will find out the cumulative frequencies, but first we have to identify the frequencies from the we will draw the cumulative frequency curve from the cumulative frequency table. So here along y-axis cumulative frequencies, and along x-axis we will take ages. So ages and years. Three, 4, 5, 6, 7, 8, and 9. Along y-axis we have 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. Now for the class interval 0 to 3 we have a cumulative frequency of 4, so it will lie somewhere here. Now for the class interval 3 to 4 we have the cumulative frequency 13, so it will be lie somewhere here. For the class interval 4 to 5 we have the cumulative frequency 25, so it will be lie somewhere here. For 6 we have the cumulative frequency 35, so it will be lies somewhere here. For the class interval 6 to 7 we will write down the values here. Here we have 41, 46, and 50. So now for the class interval 6 to 7 we have the cumulative frequency of 41, and it will be round about here. For a 7 to 8 class interval 7 to 8 we have the cumulative frequency 46, and for 8 to 9 class interval we have the cumulative frequency of 50. Now we will join these crosses with a smooth curve. This is the required cumulative frequency curve. Now to find out the position of the median we will use n divided by 2, and it will be equals to 25.
just because 50 over 2 is 25.
Now from 25 we will draw a horizontal line until it touches the commutator frequency curve. Now from the point of intersection on the commutator frequency curve.
Now from the point of intersection on the curve, we will draw a horizontal line until it touches the x-axis. So here we have the value approximately 5.5. So in the part 2, for the median is equals to 5.5 years. Now for the part 3.
Lower quartile Q1 can be found out.
Now first we estimate the position of the lower quartile, and that will be equals to n over 4. So n over 4 is equals to 50 over 4.
50 divided by 4 is equals to 12.5. Now from 12.5 it is approximately 13. So from 13 we will draw a vertical line, horizontal line that it touches the commutator frequency curve, and from the point of intersection of the curve we will draw a horizontal line, vertical, until it touches the x-axis. So here we have the value 4. So the estimated value of the lower quartile is equals to 4. Now to find out the value of the upper quartile, we will use the 3 by 4 multiplied by n, and there we have 150 divided by 4, and it will be equals to 37.5, and it will be approximately equals to 38. From 38, here we have 38 somewhere here, we will draw a horizontal line until it touches the commutator frequency curve. Now from the point of intersection on the curve we will draw a horizontal vertical line until it touches the x-axis, where we have the value 7. So the value of the upper quartile Q3 will be equals to 7. Now for the interquartile range we have the formula Q3 minus Q1. So the value of Q3 is equals to 7 and the value of Q1 is equals to
4. So we have the interquartile range is equals to 3.
Now for the question 10, the waiting times in minutes of 60 clients at a bank on a particular day were measured. The commutator frequency curve show the waiting times t minutes and the number of clients with waiting times less than or equal to t minutes. So in the part 1a, estimate the lower quartile, median and the upper quartile of the waiting times in the bank. To estimate the median from a commutator frequency curve, we find the position of the median by using n over 2. So since here n is equals to 60, by using n over 2 we have 60 over 2 and it will be equals to 30. Now we will look data value corresponding to the commutator frequency of 30, but first we have to understand the scale along x-axis. Here we have the value 2.5 minus 0 divided by 5, and it will be equals to 0.5. So each square unit along x-axis equals to 0.5. Now we have to find out the scale along y-axis. So we have 10 minus 0 divided by 5, and it will be equals to 10 over 5, and it will be further equals to 2. So each square unit along y-axis equals to 2. Now we will look the data value corresponding to the commutator frequency of 30. So we have 30. Now from 30 we will draw a horizontal line until it touches the commutator frequency curve. Now from the point of intersection on the curve we will draw a horizontal line until it touches the x-axis. So here we have the value 13. So the value of the median is equals to 13 minutes. To estimate the lower quartile from the commutative frequency curve, we find the position of the lower quartile by using n over 4, and here we have 60 over 4, and it will be equals to 15. Now we will look the data value corresponding to the commutative frequency of 15. So since we know that e squared is not along y-axis is equals to 2, so here we have 10, 12, 14, and 16. So between 14 and 16, somewhere we have 15. Now from 15, we will draw a horizontal line until it touches the commutative frequency curve. Now from the point of intersection on the curve, we will draw a vertical line until it touches the x-axis, where we have 10 minutes. So the lower quartile Q1 is equals to 10 minutes. Estimate upper quartile from the commutative frequency curve. We find the position of the upper quartile by using 3 by 4n, and it will be equals to 3 by 4 multiplied by 15 multiplied by 60. So we have 3 multiplied by 15, and it will be further equals to 45. Now we will look data value corresponding to the commutative frequency of 45. So here we have 40, 42, 44, 46. Between 44 and 46, 45. From 45 we will draw a horizontal line until it touches the commutative frequency curve. Now from the point of intersection on the curve, we will draw a horizontal line until it touches the x-axis. So here we have approximately value 15.25. So the upper quartile Q3 is equals to 15.25. In the part 1b, we have to find an estimate of the we have to estimate the interquartile range. So to find out the interquartile range, we'll use the formula estimated value of Q3 minus estimated value of Q1. So we have 15.25 minus 10, and it will be equals to 5.25 minutes. So interquartile range is equals to 15.25 minutes, 5.25 minutes. To find an estimate of the percentage of clients who waited for more than 15 minutes at the bank. So the number of clients who waited for at most 15 minutes can be found out from the commutative frequency curve. So from the commutative frequency curve, from x-axis, we will draw a vertical line until it touches the commutative frequency curve. Now, from the commutative frequency curve, we will draw a horizontal line until it touches the y-axis, where we have the value 44. So the number of clients who waited for at most 15 minutes is equals to 44. Now to find out the number of clients waited for more than 15 minutes can be found out by subtracting the number of clients who waited for at most 15 minutes from the total number of minutes, and that is 60. So 60 minus 44 will be equals to 16. So 16 clients waited for more than 15 minutes. Now to find out the percentage of the clients who waited for more than 15 minutes, to find out the percentage of clients who waited for more than 15 minutes, we will use the formula. The number of clients who waited for more than 15 minutes is 16, and the total number of clients is 60. Multiply by 100%. So this 0 cancel with 0. With the table of 2 we have 2 5s are 10 and 2 3s are 6, and here we have 26.7%. So the percentage of clients who waited for more than 15 minutes is equal to 26.7%. In the part 3, for the same 60 clients, a second cumulative frequency curve is plotted to show the waiting time t and the number of the clients with waiting times more than t times. What does the t coordinate of the point of intersection of the two cumulative curves represent? Explain your answer clearly. The t coordinate of the point of intersection of the two cumulative frequency curves is the median waiting time. In the original, cumulative frequency curve the number of clients who had waiting time less than or equal to the median. Time is the same as number of clients who had waiting. Time more than median time. In second cumulative frequency curve, number of clients who had waiting time more than the median. Median time is same as the number of clients who had waiting. Less than or equal to the median time. Therefore, the point of intersection occurs when the frequency is 30 and t coordinate is the median waiting time.